In this section, we will look at quadratic equations. A quadratic equation means that there is a variable raised to the second power, is a variable squared in our equation. When a quadratic equation is in standard form, you will have, as you notice in this gray box, ax squared plus bx plus c equals 0, where a, b, and c represent real numbers. You can use any value for a, b, or c except a cannot equal 0, because if a happened to be a value of 0, 0 times x squared means there would not be an x squared in the equation, therefore it wouldn't be quadratic. So in order to solve a quadratic equation, the problem is we need to have a new method. With linear equations, we simply combine like terms and isolate the x on one side of the equation. We can't do that with a quadratic equation when both an x squared and an x term exist. So we are going to learn some methods for solving a quadratic equation. The first one that we will look at is called the zero factor property. You may remember the term factoring from high school algebra. When you have something that has been factored, it means that you have components that are being multiplied together. Those are the factors being multiplied together. So if we can take a quadratic equation and we can factor it, there is a basic principle that will allow us to solve. As long as we've set the quadratic equation equal to 0 before we factor, then the only way I can multiply two factors together and get an answer of 0 is if either one of the factors equals 0. So if you look at this first blank, we're going to put a equals 0, or the other factor would equal 0, so b equals 0. Now typically when we have factored, we're going to have a parentheses times a parentheses. You may also recall FOIL from high school, where you would have had two parentheses with binomials inside, two terms inside, and when you multiply those parts together, you end up with something typically that is quadratic. We're doing the reverse when we factor. We start with something that has the x squared term in it and the x term in it, and we try to get it written as two factors, and those will typically be two parentheses. And if we can do that, and that was set equal to 0 before we factored, the only way two things multiplied together can equal 0 is if one or the other of those two items was equal to 0. So that's the principle we're going to follow. Now, in terms of being able to factor, if you do not recall how to factor, I would encourage you to go back to the video review lessons. There is a video review of factoring that will cover the method of how to factor. I am going to cover how to solve a quadratic equation in this video. So if you need deeper instruction, you will need to go to those review videos. So the steps we will follow is step 1, we need to make sure the equation has been set equal to 0. And if we look at this example, it is already equal to 0. 10x squared plus x minus 2 equals 0. Now, once it has been set equal to 0, then we will factor. In order to factor this, there's a number of methods that you can use, and the way that I would instruct you on that review video will be with the AC method, which is a systematic way of being able to factor. I'm going to simply assume that you know how to factor, and I'm going to take 10x squared plus x minus 2. What I know is if this factors, I would have to have one parentheses times another parentheses equals 0. And if my first pair of numbers has to multiply together when I think of using FOIL, and I would get 10x squared My only options would be 10x times 1x or 5x times 2x. I will go ahead and fill in the 5x and the 2x. Again, if you use the AC method and follow my instructions for review, you would see how to determine that these are going to be the values that you would have there. In order to get the -2 at the end, last times last had to multiply to give me -2. Well, the only way I'm going to get -2 is to multiply a 2 and a 1, and one of them would need to be a negative value. Now, the only way I'm going to make that happen is if my 2 goes here, my 1 goes here, and I am going to need a plus sign here and a minus sign here. And if I actually use FOIL to double check, I can see that 5x times 2x does give me 10x squared. My outer times outer, 5x times 1 is a plus 5x. Inner times inner, -2 times 2x is a -4x. If I add those together, it gives me a plus x. And -2 times +1 is a -2. So it's factored correctly. Again, if you don't understand how to factor, go back and watch those review videos and it will give you a detailed step-by-step instruction. Now, once you have this factored, remember our principle is the only way these two things multiply together to equal 0 is if either the first parentheses equals 0 or the second parentheses equals 0. I now have two simple linear equations I can solve. So once I set each parentheses equal to 0, I'm ready to solve. In order to get x by itself, on the left, if I add 2 to both sides of the equation, I would have 5x equals 2. To isolate the x, I would divide each side by 5. And what that tells me is that x could equal the fraction 2/5. Or, if I go to the other equation, I'm going to subtract 1 from each side. And that leaves me with 2x equals -1. Now, I'll divide each side by 2. And I end up with x equals -1/2. If I were to go back and plug those values in for x and test, I would discover that yes, I would end up with a value of 0 on the left side when I simplify. So when we have a quadratic equation, typically we will see two different solutions because after we have factored, we set each factor equal to 0 and then we solve. At this point, let's go to the next slide. And we will look at something called the square root property. We can use the square root property only with special types of quadratic equations. And by the way, I should back up and let you know when we solve by using the zero factor property, it's a great tool as long as our equation factors. We're going to discover not every quadratic equation will factor, and that's why we're going to need more than one method for solving. So when you look at the process for how to factor, you're going to discover that there's a little test you can use to see if something will factor. If it doesn't, then you're going to need to move on. Now we get to use what's called the square root property, which is illustrated on this page, if the b value is 0. In other words, we're not going to have a term that has x in it. It's just going to have the x squared and the constant. So if that happens, remember that I can get rid of a square by taking the square root. So if I were to take something like, and I'm going to go ahead and give you a quick example here. Let's say x squared was equal to 25. And I asked you, what value would x be to make this true? Most of you would probably instantly tell me 5. That's half right. It's not every solution to this problem. Remember I said to get rid of the square, we could take the square root of each side. And what we need to remember is there's both a positive and a negative root. This equation, the way that it's written, is asking what number can you multiply times itself, and the answer is 25. Well, 5 times 5 is 25, but so is negative 5 times negative 5. So if I have to put the square root into the problem in order to solve, I have to remember that there's both a positive and negative root, and you need to make sure you put a plus or minus on the right side so that you will get x equals plus or minus 5 in this example that I gave you. Therefore, if you have a quadratic equation, and it's quadratic because there's an x squared in it, but there is no x term, then you will have two solutions for the solution set of x squared equals k. X would either be a positive square root of k or a negative square root of k. And if you wanted to write it in a shortcut form, you could do it the way that I did when I wrote plus or minus 5. You can put the plus or minus in front of the square root of whatever number it is that you were solving. I will tell you on the homework that you do in the computer, it will not allow you to use the plus or minus and write them together. You will need to separate them with a comma and write it as the positive number, comma, and then the negative value. So let's go through a few examples of how to use the square root property. The first example we have is x squared equals 29. Again, I see an x squared, I don't see an x term. So what I'm going to do is take the square root of each side. But I have to remember, because I am putting the square root into the problem, there is both a positive and a negative root. So I'll squeeze that plus or minus in front. On the left side, square root of x squared is just x. And that means my answer is x equals plus or minus square root of 29. Now, I do need to see if that would that radical would simplify. But if you double check, 29 is a prime number. The only thing that goes into 29 evenly is itself in 1. So it does not simplify any further. Now if I look at the next one, x squared equals negative 144, again, I do not have an x term. The b value was 0. So I can take the square root of each side. But I better squeeze in that plus or minus on the right. I've got to remember there's both a positive and a negative root. So x equals, now on the right, I know I have the plus or minus. Notice on this one there is a negative number under the radical. What does that mean that I need to do? Take my I out, remember? So I would have I times the square root of 144, and if I double check, 144 is a perfect square. That will give me a final answer of x equals plus or minus 12i. So you may have a complex number as your answer when you're using the square root property, and that's perfectly fine. Now if you look at example C, it looks different from the others, and that's because there's more than just the x being squared. I have a parentheses being squared. And the x is inside the parentheses. Remember, my goal is still to get to where I have just the x isolated. So in order to do that, the first thing I need to get rid of is the square. How do I do that? Again, I'm going to take the square root of each side. So the left side, the x minus 8 in parentheses squared, I'll take the square root of that. Now on the right side, when I take the square root of 24, don't forget, it's both a positive and a negative. And when I look at that radical, I think there's a possibility it could simplify. So I'm going to come out here to the side and do my prime factorization. That's an even number, so 2 will go into 24 12 times. 2 goes into 12 6 times, and 2 goes into 6 3 times. Now remember, I'm looking for pairs. Square root means what can you multiply times itself. I have a pair of 2's. The fact that there's an extra 2, it just stays there. I don't circle it up. But that would tell me when I get ready to clean all of this up, I know the left side, the square root will cancel out the square, and all I will have on the left is x minus 8 equals, I've got my plus or minus. Now when I simplify square root of 24, what I've circled, the pair of 2's, I'm going to have a 2 that comes outside. What I didn't circle, I multiply back together. 2 times 3 is 6. That will stay under the radical. So right now I have x minus 8 equals plus or minus 2 times the square root of 6. I'm almost done. Remember, my goal is to solve for x. I can add 8 to each side, and that will get the x by itself. And x would equal 8 plus 2 square root of 6, comma, 8 minus 2 square root of 6. If you were typing it in the computer, that's the way the computer would want you to type it in. Okay, so we've learned 2 methods so far. We can solve by factoring as long as our quadratic equation is factorable. We can solve by using the square root property as long as the b value is 0 and I don't have an x term. We need something that would work all the time, and that's going to be the third method we look at, which is on the next slide. The quadratic equation formula is a tool that will allow you to solve any quadratic equation. It's written for you here on this page. If we were in a face-to-face class, I would probably make you sing a little song to try to memorize it. I'm hoping it looks familiar to you. If not, you want to spend a little time studying it. But the a, the b, and the c simply come from that quadratic equation. The a is the coefficient in front of the x squared, the b is the coefficient in front of the x, the c is the constant when the equation has been set equal to 0. And we would then take those values and plug into this formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to go through a few examples where we practice using the quadratic formula and see if we can get the hang of this. Now, the first step, before you do anything, you have to make sure your equation is set equal to 0. We do not solve quadratic equations until we have set them equal to 0. The one exception to that is if we're using the square root property. So we've got to set it equal to 0 before we can identify a, b, and c. When I look at x squared plus 6x equals 3, obviously it is not set equal to 0, so I will subtract 3 from each side, and that will give me x squared plus 6x minus 3 equals 0. Now I can identify a, b, and c. Now the a is the value that's in front of the x squared. I don't see a number. Remember, it's understood to be 1. If we don't see it, it's 1. B is the value 6. C is negative 3. My signs are very important here, so I need to make sure I've written everything carefully and that I include the correct signs when I identify A, B, and C. So we're going to find A, B, and C, which we just did, and we will substitute those values into the quadratic equation formula, which means we need to write down the formula. So the formula is x equals negative b plus or minus the square root of b squared minus 4ac, all of it over 2a. Now, my recommendation is, before you try to evaluate this, I would put parentheses everywhere you had a variable, and then you can plug in those values that you found. So the first parentheses is a b, that's 6. This is a b, so that's a 6. The a value was 1, the c value was negative 3, and the a value is 1. Now, once I have substituted those values in, it's time to simplify. So we're going to put that down in the blank for step 3. And the way we simplify is we begin with the radicand. Now, radicand is simply the term that means the value that's underneath the radical. It has another name. We sometimes refer to it as the discriminant, and we're going to speak more about that when we move to the next page. So I need to find that value that goes underneath the radical before I worry about any of the rest of the cleanup. So let's look at that. If I square 6, I'm going to get 36. I'm going to come over here, and I'm going to fill this in. 36 minus 4 times 1 times negative 3 is plus 12. That means I've got the square root of 48 that I'm trying to clean up. Now, if you are comfortable with your calculator skills, you could actually put this in the calculator, but here's a word of caution. If I try to put the square root of 48 in my calculator, it is going to give me some ugly decimal value, and I need to answer this in simplified radical form. I have to simplify the square root of 48 as we did back in the previous homework lesson. So I'm going to need to do prime factorization. If I take 48 and I do the prime factorization, 2 goes into 48 24 times, 2 goes into 24 12 times, 2 goes into 12 6 times, and then I'll have a 2 and a 3. Now notice I have a number of 2's here, but remember I'm circling pairs. So here's a pair of 2's, here's another pair of 2's. I have 2 groups I have circled. Anything that's circled is going to come to the outside. So I take a 2 from the first circle, a 2 from the second circle, multiply them together, and that means I'm going to have a 4 that is outside the radical. The value I didn't circle that stays under the radical is the 3. And then, as we practiced in the prior homework, I can separate this into 2 fractions by putting the denominator as 2 under the first part. In this case, it's not a real and an imaginary, but it's a rational and an irrational part. And typically, the computer does want you to type it in separately instead of as one big fraction. But notice this is going to clean up nicely for us, because the rational part, negative 6 divided by 2, is a negative 3. 2 is the common factor. Plus or minus. In the second, the irrational part, 4 divided by 2 is 2, and I have 2 times the square root of 3. My answer would be x equals negative 3 plus or minus 2 times the square root of 3. That would be an example of how to use the quadratic formula and simplify a radical. Now, that was a real number solution. It's possible we could get a non-real complex solution. So let's look at this next example. And what we see is the equation is 4x squared equals 3x minus 5. Now remember, step 1 said that my equation needs to be set equal to what? To 0. I can decide which side I want to move the terms to. I can move them all to the left, or I can move them all to the right. It won't make any difference. The signs will take care of themselves as we clean up. So let's say that we move the 4x squared to the right by subtracting 4x squared from each side, and we'll have 0 equals negative 4x squared plus 3x minus 5. So we set it equal to 0. That will give me an a value of negative 4. B is going to equal positive 3, and C would equal negative 5. What I need to do now is plug into that quadratic formula. Be sure you write it down. X equals negative b plus or minus the square root of b squared minus 4ac, all of it over 2a. Now, I want to go back, and I'll replace each of those variables with a parentheses, and then I will substitute in these values that I just found for A, B, and C. My B value was 3. The A value was -4. C was -5. And on the bottom, A was -4. So again, we're going to need to clean up underneath the radical. If I take 3 and I square it, that would give me 9. If I take -4 times -4 times -5, 3 negatives multiplied together would be a negative, and those numbers would multiply to give me 80. Well, 9 minus 80 is a -71. What I have is x equals -3 plus or minus the square root of -71 over -8. Now, I need to see if that radical simplifies. What I should pay attention to is I see a negative under there. What does that mean? I definitely have to take care of. I'm going to need to take the I out. The number part, though, 71, is actually a prime number. There's not going to be any factors that I can pull out of the radical. So when I finish cleaning this up, I would have x equals -3 plus or minus I square root of 71, and I could put each of these over -8. What's going to happen is the signs would clean up. So this is where it kind of takes care of whether I move it all to the left or I move it all to the right. You could write it this way, or you could write it as x equals 3/8 plus or minus I square root of 71 over 8. Again, with the negative on bottom and a plus or minus on top, it's going to end up giving me the same values back, whether the 8 was negative on bottom or whether it was positive. If you wanted to leave it as one big fraction, you could leave it as -3 plus or minus I square root of 71, all of it over -8. Perfectly okay if you're writing on paper. You'll just have to pay careful attention to the instructions on the computer. Now let's move to the last page and we'll speak a bit more about the discriminant. The discriminant is simply that number that's under the radical. So in our quadratic equation formula, what's under the radical is the b squared minus 4ac. Simply by looking at that value, it will tell me something about the kind of answer I would get, the kind of solution that I would get. And so let's fill in this table. It will explain to us the number of solutions and the type based on the value of just the b squared minus 4ac. The nice thing about this is I don't have to do the entire formula. All I need to do is find b squared minus 4ac, and from that I can answer these questions. Now, if the number that I get underneath the radical is positive and it's a perfect square, something like 25. When I take the square root of 25, I would get 5, and my radical would not be there anymore. But remember, in the formula, there's a plus or minus in front of the radical part. So I would have something plus 5 divided by the denominator, but then I would also have something minus 5 divided by the denominator. The fact that there is something remaining after the plus or minus means I have two solutions, because I have to do it one time with a plus sign and a second time with a minus sign. Now, as far as the type of solutions, if it's a positive number under the radical and it's a perfect square, which makes the radical disappear, all I have left will be a rational number. In other words, it's something, a real number that could be written as a fraction. It doesn't necessarily have to be a fraction. The fraction could clean up to be a whole number, but it could be written as a fraction. It's not going to have the radical in it or a decimal or anything such as that. Now, if it turns out that the number under the radical, the b squared minus 4ac part, is positive, but it's not a perfect square, then what that tells me is I have something like the square root of 48, which we looked at a moment ago, or I have something like the square root of 24, which we also looked at that, which means I'm going to simplify the radical, but the radical won't completely go away. Not everything will come outside. So I still have something after the plus or minus sign, which means I have two solutions, but the radical is there. And as long as it's positive, I know I don't have an I, but I do have the radical, which means my solution is not rational. It's an irrational number. If I have the square root of a positive number that's not a perfect square, that's irrational. If I put it in the calculator, I get a decimal number that doesn't end and doesn't repeat. Okay? So I've covered all the possibilities of what I get if the number is positive under the radical. We've got another option. I could get 0. I could do b squared minus 4ac, and I get the number 0. Now, here's what that would mean. The square root of 0 is 0. And there's a plus or minus in front of that. So if I have some number and I add 0, is it different from that number minus 0? No. I'm not going to have two solutions anymore. I'm going to have only one solution. Basically, that quadratic formula is going to simplify to be negative b over 2a because everything under the radical became 0. And that means I'm going to have a rational solution, but only one. Now, when I get a negative value under the radical, we were working with those back in section 1.3. I know I can take care of it as long as I'm able to use complex numbers. It means I'm going to have an I. I would take the I out. That still leaves me something after the plus or minus sign, so I will have two solutions, but the answer will have an I in it. And if that's the case, then I have two non-real complex solutions. Okay, so instead of completely solving these using the quadratic formula, we are simply going to find the value of the discriminant and then state how many and what kind of solutions we know that means this equation would have. If I look at example A, now remember it still has to be equal to 0 before I identify A, B, and C. And this one is equal to 0. So that tells me that A is 4, B is negative 12, and C would be positive 9. Remember, I don't need the entire thing. I just want to see what b squared minus 4ac is. I'm not even putting a radical around it. I'm just looking at the value of this number. So if I substitute parentheses for each variable, and now I plug in, my b was a negative 12. The parentheses are really helpful to make sure you don't mess up on signs. The a value is 4, and the c value is 9. So I have, and this was a 4, I know that was a little sloppy, negative 12, when I square that, gives me a positive 144. Negative 12 times negative 12 is positive 144. So if you're putting that in a calculator, be very careful that you use parentheses. Minus 4 times 4 times 9. Well, if I multiply 4 times 4 times 9, I get 144. So I have 144 minus 144. That equals 0. Now from the table, what does that tell me? How many solutions and what kind? I have one rational solution. Now notice I don't know what it is. I haven't used the quadratic formula to find the solution itself. I just know there's going to be one and it's going to be rational. And I'm done because that's all it asked me for. Now when I look at B and I look at C, I have to do some rearranging first because these are not set equal to 0. In the case of B, it would be easier to move everything to the left and add 5 to each side. So this becomes 3x squared plus x plus 5 equals 0, which means A is 3, B is 1, because I don't see a number in front of the x, C is 5. Okay, let's see what b squared minus 4ac is. Again, I'll use the parentheses, and now I'll plug in. The b is 1, the a was 3, the c is 5. Now, if I square 1, I just get 1, and then minus 4 times 3 times 5 That's minus 60. 1 minus 60 is a negative 59. What would a discriminant value of negative 59 tell me? Well, if I look at the table, I have two solutions and they are non-real complex. Got the idea? Here's the last example. When I look at C, I think it would be easier to move everything to the right, so I'm going to subtract 2x squared from each side. 0 would equal negative 2x squared plus 6x plus 7, which means A is negative 2, B is 6, C is a positive 7. All right, we need to evaluate what b squared minus 4ac equals. So it's time to substitute in. The b value was 6. The a value was negative 2. The c value was 7. So if I square the 6, that's 36. And then a minus 4 times a negative 2 times a positive 7. I have two negatives being multiplied there, which will turn it into a positive. And 4 times 2 is 8, and 8 times 7 is 56. When I add those together, I get a positive 92. Now, it's positive. I have to decide, is it a perfect square or not a perfect square? I can check that easily in the calculator. Square root of 92 is a nasty decimal. Therefore, I have two solutions that are irrational because it's not a perfect square.